fit. After the adhesive cures, nearly 2 hours later, this is a solid, inseparable cylinder which, as per the certification label, conforms to the standards required by government regulators. Every single cylinder this factory produces undergoes safety tests. This one, in a pressurized chamber, ensures the cylinder can hold the required amount of pressure. This submersion test ensures the cylinder is gas-tight. If bubbles appear in the water, it means there's a leak. After a cylinder passes testing, workers install the valve, which is already connected to the overfill prevention device. The valving machine holds the cylinder steady while it turns the valve to the precise tightness the engineering specifications require. Now it's just a matter of snapping together the cylinder's two-part plastic housing. The housing has handles for carrying the cylinder. It also has a flat base to allow the cylinder to stand upright. Composite propane cylinders come in various sizes to fuel everything, from barbecues to patio heaters, even ride-on lawnmowers and factory forklifts. Salsa is a staple of Mexican and southwestern cuisine. A spicy tomato-based condiment people typically enjoy as a topping on tacos or dip for tortilla chips. Recipes vary, as does the kick factor, from mild to extra hot. Salsa is the Spanish word for sauce. This American company produces 9 different flavors, from regular to roasted garlic to pineapple mango. All flavors begin with fresh tomatoes, delivered daily to the factory. Workers inspect them carefully and remove any stems, leaves, and unripe or imperfect tomatoes. Other workers, meanwhile, cut the stems off cilantro, a leafy herb that acts as a major flavor enhancer. They wash the cilantro in a tank of ice-cold water, then transfer it to another cold water tank for a second wash, and then to another tank for a third wash, then a fourth and final wash. This one in a machine with food-safe vegetable sanitizer containing bacteria-killing hydrogen peroxide. Then they dry the wet cilantro in a giant salad spinner. In another area, they prep the onions, peeling the skin and slicing off the ends. They rinse the onions with water and the same sanitizer they used on the cilantro. Ditto with the tomatoes. This industrial-strength dicing machine chops up all the produce ingredients. It has interchangeable blades to adjust for different-sized cuts. First through the dicer, the tomatoes. They enter whole and exit in pieces about 1 centimeter big. Next, the onions. The dicer chops them into pieces roughly 1/2 centimeter in size. Meanwhile, the cilantro goes into a cutter, which chops it into fine pieces. The recipe proportions are roughly 80% tomatoes, 5% onions, 2% cilantro, 5% green peppers, then additional flavor-specific ingredients, plus salt, pepper, and vinegar. With the prep work done, it's now time to blend all the ingredients in a giant mixer. Each batch begins with 208 liters of tomatoes. Next comes the cilantro. This and all the ingredients are pre-weighed so as to be in the correct proportion to the quantity of tomatoes. The onions are next. This particular batch of salsa is garlic artichoke flavor, hence the next ingredient, diced artichokes. Now the combined liquid ingredients, lemon juice, lime juice, and white vinegar. Followed by the combined dry ingredients, salt, pepper, dried celery, and garlic powder. A final high-speed 5-minute mix ensures everything is thoroughly blended and ready for packaging. The finished salsa goes into vats. From there, at packaging time, a pumping system moves it to the automated filling machine, whose nozzles squirt the required quantity of salsa into plastic containers. The machine then seals each container with a plastic safety film and presses on a cover. This is what the packaging process looks like in slow motion. It actually moves at about twice this speed. The filled containers now pass through a combination X-ray metal detector. On the off chance a foreign object fell into the salsa during production, the machine flags the affected container and triggers an automated arm to eject it from the production line. This standard food safety precaution ensures that every single container proceeding to labeling and then onto store shelves is A-OK. To pump water from the ground, the windmill reaches to the sky. The blades catch the breeze and spin, while gears convert the spinning action into pumping action. This technology has been around for over 2,000 years. The first known water-pumping windmills originated in Persia around 7 AD. In 19th century America, this was the Wheel of Progress, a metal-bladed windmill that turned with greater force than traditional wooden ones, even in low wind conditions. Its superior pumping capacity made it indispensable to pioneers settling inland, away from rivers and streams. Today, the same design continues to be part of the rural landscape, especially where there's no electricity to run water pumps. Production begins with a 100-ton punch press. Once activated, it cuts triangular shapes from galvanized steel sheets, each with a slot in the center. Each cutout will be a windmill sail. They'll need 18 for each wind wheel. Once stacked, they transfer the sail shapes to a rolling station. The roller curls the steel to an exact curvature, producing a slightly bowed shape, which will efficiently capture the wind. Next, a worker wraps a metal rib around each sail. He taps the sides until it fits snugly to the sail. The rib has a tab that slots into the hole in the sail's center, allowing the two parts to interlock. Bands fit through the ribs to assemble the sails in groups of 3. Next, a worker slides a metal loop over the guide wheel and drives the ends into holes in the gearbox using a sledgehammer. He rivets the ends to the gearbox so that they're solidly ensconced. Next, he inserts the windwheel hub and shaft into the main frame of the gearbox. He taps it to nudge it tightly into place. He then grinds the brake lever to shape it to the brake mechanism on the hub. This braking system is critical. It will stop the windwheel from spinning out of control in high winds. He spins the hub and activates the brake several times to confirm that his machining is dead on and that the brake system works perfectly. If it doesn't, he makes adjustments. Next, using a very toothy circular cutter, he carves grooves into steel blanks to shape the gears. The difference is quite obvious. He installs a set of these gears at the base of the metal loop and secures them with a metal pin. He checks their turning radius, and then mates a larger set of gears to the smaller ones, ensuring that the teeth intermesh. This very substantial gear system will drive the guide wheel, creating the pumping action. Two metal parts called pitman arms link the gears to the guide wheel. A steel pin holds everything together. As the gears turn, the guide wheel rolls up and down the loop to complete a pumping cycle. Next, he screws a series of thin metal rods to the hub. They're called wheel arms, and they hold the windmill sails. The wheel arms fit into pre-cut holes in the structure of the sail sections. He secures the assembly with nuts. Once all the sail sections have been mounted to the wheel arms, the windmill is ready for a spin. It's a test run to confirm the wind wheel and gears function flawlessly. It takes a crane to lift the 290-kilogram windmill to the top of its tower. Once it's in position, a worker guides the gearbox onto the mast pipe. When it's secure, they hoist the helmet. It's a cone-shaped metal cap that will protect the gears from the elements. He bolts it to the top of the gearbox. With that job done, this windmill is ready to pump. It should last decades, providing water that is as free as the wind. Dragsters roar out of the starting line in a cloud of smoke, and then it's a blur. Traveling at speeds of up to 515 kilometers an hour, these hot rods rip through a 400-meter racetrack in less than 4 seconds. It's why they need parachutes to slow down and come in for a safe landing. Blink a couple of times and the race is over. Packing an incredible 8,000 horsepower, a dragster is at least 50 times more powerful than a subcompact car. With fat rear tires for traction and a tapered aerodynamic body, the dragster is engineered for one thing only: speed. Production begins with the heart of the vehicle, the powerful 8-cylinder engine. To reduce drag, the engine block is made of lightweight aluminum. A technician carefully installs the camshaft, then fastens the timing cover to the front of the engine. The timing cover prevents oil leaks. He installs the crankshaft and hub. And once the 8 rods and pistons have been loaded and connected, he tests their movement and function. Satisfied with their performance, he encases them in an oil pan. With the installation of the drive gears and other components, the engine block is now complete. They move on to the supercharger, a forceful blower that boosts engine power tremendously. This worker seals the seams with urethane and caps the ends. He slides strips of Teflon between the